Well, good day. Hello. Welcome to the exida webinar on FMEA, instant failure modes. Now, I'm going to explain what I mean by that, because that's clearly the impression I got when I started using this particular tool that we'll talk about today. You know what an FMEA is, certainly if you've attended our previous webinars. And we are, the problem, of course, I'll repeat it, is that the word means so many different things to different people. In this webinar, we're focused on design verification. We're going to be doing a failure mode and effect analysis on a given architecture design. This can be done at different levels, from the systems level down to a more detailed level. But in general, we do not go to the component level, at least not in the model, concept that we use at exida. You know also by now that FMEAs are tremendously valuable and have been shown over and over again to pay for themselves, because if you find a problem early in development, you have the potential to save a lot of rework. And I know I told you before that I have clearly been the victim of that many years ago when I was managing a new product development group. In this webinar, we'll talk about FMEA experience and identify the issues that seem to take so much time. One of the main reasons I've heard people complain about FMEAs, not that they don't work, but they just take too many engineering hours. We'll discuss that, potential solutions, what are the issues as to why a lot of engineering hours are consumed. Is there anything we can do about that? And we will give you a functional architecture design. Remember that this is one of the webinars on the Fall FMEA webinar series. I hope you've been able to watch the previous ones, and I hope you tune in for the rest. They will all be available from the exida website or on the exida YouTube channel. Now, I'll introduce myself briefly. My name is Bill Goebel. I was one of the co-founders of exida back in very early 2000. I am very proud that exida has grown into a large global company. We are experts in functional safety, alarm management, and cybersecurity. And speaking for myself, I enjoy our work very much, and I'm looking forward to even more of it. One of the engineering companies is Exida Innovation, LLC, and that company develops and sells engineering tools, software. One group of tools is for systems level design, Excellentia, primarily oriented toward process and machine safety applications. OEMX, on the lower part of your screen, is a suite of engineering applications focused on new product development work. And quite frankly, these tools came from usage in our certification department, where our evaluating assessors would go out and facilitate process improvement in new product development, as many people wanted their products certified for functional safety or for cybersecurity. We're pleased that that certification group has grown to be a global leader in many markets and a strong contender globally for all functional safety certification. I told you we were technical geeks, or at least I should have, and I'm proud of the name. We develop, we create, we study, we learn but we don't keep it to ourselves. We publish it in our books, our white papers, our courses, and our webinars. And we like to distribute our knowledge and help train the world to be a safer place. Now, we talked briefly about what is failure modes and effects analysis. Again, I have the ASQ definition in front of every one of these webinars. We are focused on the concept of a design FMEA. We're not working with process FMEAs or procedural FMEAs, design FMEAs, because we are looking for design issues, problems, we should probably call them, in architecture designs, which occur early in the development process. FMEA is very systematic, and it's primarily created to find problems and to recommend solutions to those problems, which we call mitigations. It's systematic in that we look at an entire system, one block at a time, through one or more levels of design. The objectives then should be very clear. Number one, find problems, starting at the high-level architecture. Recommend solutions or mitigations. How do you fix the problem? And there's a few more. We want to update requirements as new mitigations are chosen. It's an ideal time to define integration tests, sometimes to show that a particular failure mode is impossible or at least unlikely. Provide inputs to a failure mode effect and diagnostic analysis if you want the quantitative failure rate and useful life predictions. Document the design choices, which is an important one, and it's even valuable to train new staff members. They don't necessarily contribute, but they can sit in and learn a whole lot from your more experienced designers. And lastly, we have to achieve all these objectives with the minimum engineering hours. I've been through a lot of FMEAs as a facilitator. In one particular one that I remember very well, we were using, it was a software FMEA, and for each functional block, we defined what is the block, what is the function of that block, and then we used guide words to brainstorm what the failure modes of the software block might be. As one of the failure modes was announced, one of the engineers said, you can read it, "That's it, I've been looking for this cause of software field failure for weeks." It was existing software they were going to use in a new product. My gosh, that's the cause of the problem. This particular failure mode in this particular software unit. And of course, the department manager said, you just paid for yourself many times over. That's very satisfying. But then he looked at the group and the time, and it basically took a whole calendar week. The total runtime was 30 hours. There was a team of 6 engineers. My goodness, he said, that was a lot of engineering hours. He may have to take his statement back again. 180 person hours. And that's the fundamental problem. I heard from other engineering managers about FMEA, and they say things like, oh yes, we obviously must do FMEA for all our safety critical designs, both hardware and software. And certainly we must, you certification people are forcing us to do FMEAs. But, and you know, I guess they pay for themselves, but we're not doing FMEAs on all of our designs, only the safety critical designs. And I thought that was sad. I was disappointed. And I thought to myself, why not? And the fundamental answer was, it takes too many engineering hours. FMEAs are valuable. Just think how much time you could save later on if you do reduce rework, which in the end reduces cost and time to market. And wouldn't it be great if there were easier and faster way to do FMEAs? And that's something we started to work on many years ago. And I think I can show you some of the results of that effort. Keep in mind, even the minimum FMEA team, which is a facilitator, a describe, a design engineer, as minimum, and in many cases, a test engineer who can document the integration and validation tests during the FMEA as the need becomes obvious, which it does in an FMEA. Now, I know the concept of defining integration tests and validation tests during an FMEA is not common, but I cannot imagine a better time and place to do it in order to achieve that other important goal, minimizing engineering hours. So I started asking a lot of people over the last few years, what's the matter with FMEAs? And of course, having gone through quite a few of them myself, they're time consuming. Engineering managers care about that. Often they are boring, especially if you bring in too many people. I don't want to be sitting here talking about failure modes. I want to go start designing the circuit. I want to go start writing the code. And that's just so natural. Engineers, I think, are by nature people who want to design and create something new. And the fourth one, I was a little surprised. You know, most of the time we only find small issues and problems. Well, let's take a deeper look. Why is it time consuming? Well, the use of guide words, which has been our mainstay for at least for maybe 22 decades now, because we don't have well-known failure modes for functional blocks, especially software blocks. All you can really do is look at what is the function and then use the guide words to help you brainstorm the failure modes. And that's what I did for many years. Number two, many of the FMEA procedures created by companies are really quite complex. And some of the things I still recommend are, do not bother talking about. Don't bother talking about the cause unless you really have to. I mean, I know why people put it down there. They're trying to justify eliminating it as a likely failure mode, but I think we should just move past that, and I'll show you some examples why. Many of the multi-level FMEAs, it requires tracing, right? You're working at the lowest level and you have to trace the effect up all the way through many levels to the top level of design. I've seen these spreadsheets are huge and long and many columns, and it just gets confusing, and it sure would be better if we work top down, not bottom up. And lastly, I've seen the FMEA repeated for each operational phase of a product, you know, normal operation, maintenance, and that's okay, but I do recommend separating them into separate FMEAs with different people. Trying to get everybody in the same group, a large group, just takes more time. RPN numbers have been highly debated because I've been in FMEAs where everybody just argues about which number to pick. And there's often a lot of debate about the possible solutions to problems which have been identified, the mitigations, because you have to argue about effectiveness and cost and design time. And lastly, the larger the team, the more hours you suck up, which is kind of an obvious issue. So minimize the design team, the FMEA team. What about boring? I've heard one person say it's like being an airline pilot. Most of the time it's very boring until it isn't, in which case it's scary. A pilot told me that. And if you have a large group, the maintenance people, the operators, the marketing, many of those people are going to be bored, and I have seen them doze off. Kind of not useful, waste of time. Everybody wants to get moving with the design, and quite frankly, I always did. I still have that tendency, but I think we have to make sure people understand that they can save themselves hours and save calendar time by using the best design verification techniques available. And I think FMEA is one of the best, if not the best. Now, I'm not sure why sometimes people only find small problems. Now, quite frankly, a really good design done by a really good designer will indeed only have small issues and problems. When I was a development manager, I had one or two guys who, for some reason, just got things right. I kind of learned not to push them all that hard. I'd even let some of these people skip the FMEA based on their positive level of experience, but you probably should go through at least an abbreviated FMEA anyway. But more importantly, if you can reduce the time for an FMEA, you can go ahead and run it even for those really good engineers who rarely ever have problems. How can we get through FMEAs much faster? Simplify, streamline are words that pop into my head. If we expect so many recommendations that we have to prioritize them, number one, use high, medium, and low, not RPN numbers. I've heard some people are doing that already. If it's safety critical, it's a 10, 10, 10. If it's not important, it's a 1, 1, 1. And rarely do they ever put anything in between that. I guess if it's a safe failure, it's a middle number of 5. 1, 5, and 10 are the only numbers they use. Okay, that's like high, medium, and low, if you think about it. So it's already happening, even if your tool only allows RPN numbers to be used. Pick a subset. Wouldn't it be great if over time we could develop and document libraries of failure modes, even for functional blocks? If we had them, we could use the guide words only when the library does not exist. Number 3, we could develop and document well-known proven mitigations. Now, the hard part about that is document. And how do you do that? Every time you do an FMEA, you got to write this stuff down. You have to document it later. You have to kind of build up the library. And if your engineers are like me, I hate documentation. And sometimes this stuff just does not get done. Focus on the design, not operations and maintenance. Focus on the design because we're trying to save design man hours, and we're trying to get the design to market in the minimum calendar time. If you need more FMEAs, separate them into different sessions with different groups. And absolutely don't enter anything you don't need. Just because it's on the tool or you have a column for it in your spreadsheet, don't use it if you don't need it. I have truly, it makes me sad to see some FMEAs where the engineer wasn't actually well trained and ended up using all the extra boxes that are only needed in rare circumstances. Don't use anything you don't need. I believe, and I have seen, that FMEA tools are much better than spreadsheets. There are many FMEA tools on the market right now. I've not used them all. I used to use one some years ago, and right now I'm only using the one available from Exida, which we call ArcX. And I'm going to talk about that a little bit more. For example, in this tool, we only use high, medium, and low. We only have likelihood and severity. And you can enter high, medium, or low, or nothing if you don't need priority. Think, enter fast, or don't enter at all. This tool does have failure mode libraries as a function of block type that were documented over many years of many FMEAs that we have facilitated. This tool does have failure mitigations for each failure mode. Well known, documented public solutions. The proprietary information cannot go here, of course. And now that I'm thinking about this, wouldn't it be great if you could enter your own failure modes and your own proprietary mitigation techniques into this library mechanism? And with this tool, you absolutely can. You can capture your own corporate intellectual property, and it's there for subsequent users after you log it in. Now I'm going to work on a little demo here for you of this tool so I can show you exactly what we mean. I loaded up the tool. We have a blank screen to get started. I mean, I could go ahead and enter project details, and that's where there's all kinds of information you can enter. It's primarily valuable when you go to issue reports because it'll have all this information. I'll probably put in that's all I need for now. There's lots of other things you could enter, but you don't have to. Remember, don't enter anything you don't have to. Maybe you can enter it later if you wish before you generate those reports. Now I'm going to use the right click. I'm going to enter a top level unit, and I'll just call it the limit controller because I want it used. I want to group all the subsystems together. Now, under the limit controller, you remember on our architecture diagram, I had a power supply. It's a hardware type block, but I'd rather have more detail, so I want to identify that this is a hardware power supply type block. Now we do have a needs review here. I know these don't need review, but if I wanted to make sure they were reviewed, I would leave that unchecked. For this power supply, I don't have an instant FMEA yet, but I'm going to launch the deviation expert knowledge, which means I want some failure modes. Now, what is the type? It's hardware power supply. There's a more detail. Oh my goodness, look what happened. I just got a list of failure modes in blue and quote recommendations in pink. They're kind of pink on my screen. I know from my requirements that I do have a low voltage monitor. I do have an over voltage limiter. So I'm going to get rid of the, I'm going to get rid of the quote mitigations, especially the one that says no effective measure. I mean, it's there when you just, okay, I don't have anything for this. And I'm going to hit this load subtree button. Oh my goodness, look what happened. I just got what, this is where the word instant FMEA came into my mind. This is great. I'm going to go back to the unit editor, go up to the limit controller. Let's go ahead and get rid of the review. What else is on my, what else? I have an analog input. It's a 4 to 20 milliamp. So I'll give it that title. It's hardware. I could probably figure out, I go into more detail. I don't want any review right now. Okay, I entered the unit, the architectural unit. Launch my deviation screen. Here's where the magic occurs. Since I entered the hardware unit, oh my goodness, look at that. Well, I've got a lot of mitigations here. I'm going to deselect everything for a couple reasons. Yeah, drift is a valid failure mode. I'm going to, but this outside normal range, I don't think that's a valid failure mode. Insufficient. All right, now if I have drift, I know I have a double point verification. I know online calibration. I have no effective measure for that. All right, load subtree. Wow, I'm getting there fast. Now it's getting a little complicated because I need to add the microcontroller. I've got a small microcomputer on here, and that is clearly hardware. Let's just say hardware at this point. And in that microcontroller, I have, whoops, I entered it in the wrong place. I just hit delete, and it works exactly the way you think it did. I want the microcontroller, add a unit. That's I want a subunit, fine. I have a number of subunits here, and the processor core is probably the most significant. Let me just see, what kind of a block is that? Microprocessor core. Okay. I'm a little scared. This is complicated. Right click, launch the deviation expert library. Now, what kind of a block is this? Oh, it gives me, I already told it, so it gave me, oh, look at all that. There's a lot of failure modes here. Let me zip through the failure modes first. Yeah, I have internal registers. I've got an ALU. I've got an address calculations. I have interrupt handling. Hold it. I do not have a cache. And therefore, I don't have to worry about single unit upset errors on my cache. And of course, I don't need any of these mitigations. Make sure we got them all. We did. Now, I do have internal registers. I look up I check my diagnostic list. I don't have anything for internal register detection. Okay, let me tell it like it is. Coding and execution. You know what I have here? I have multiple reasonability checks. I'm not going to run any CPU test. I'm not going to do any of this stuff, but I've got multiple reasonability checks. Now over here, I know I have program flow control monitoring, and that's the only one I have. The program flow control monitoring has program sequence monitoring, an unbelievably effective diagnostic. And I don't need any, I'm hoping I don't need anything else. I've just identified the valid failure modes from a list of suggestions. I've just identified potential mitigations from a list of known, proven. Oh, that's nice. Now, all I've got my failure modes, I've got recommendations. What about the effect? Oh, well, let's go back to this failure mode. What's the effect of this failure mode? Well, in our world, we have a list of the potential systems level impacts. We just go right to the top. We have a de-energized to trip system, so that's a safe fault. Power supply low will be a safe fault. A noisy power supply, geez, I don't know. It depends how noisy it is. I'm going to pick a safe dangerous split. A high voltage. You know, that's dangerous. I just don't know what's going to happen. We're going to make sure it's dangerous. A high. I don't think we can get a high. We have a limiter. Okay. I should have remembered. I shouldn't have checked that one. That's okay. I can delete it. Oop, it's gone. Now that's cool. So all I have to do is go through input drifts. That's dangerous. I don't like it. If input stuck, that's dangerous. Internal core. I'm pretty sure these are nasty failures that we do not want to happen. So we're going to leave them all dangerous. I still have to add the output module, and we could do that. Boy, I didn't think this would. I didn't think this would get done that fast. I'm going to go ahead and enter the digital output. I'll call it discrete output. It's hardware. Maybe I can figure out it's a hardware switch. Fine. I don't need anything else. Now, let me lift this up. Right click, load the deviation expert knowledge. I have to make sure, what kind of switch? Is it high side? In other words, does it source current? Is it smart? Yeah. Oh, I like that. I really like that. It might be stuck energized. Fine. We can't get under voltage shut down. We don't need it. We don't want it. We don't have it. We're not going to limit current. Actually, we do. Okay. If it's stuck energized, we have a pulse test we've implemented. Pulse test with independent readback. We've got all that. I know them from our requirements. We could theoretically design in a current limit. Maybe I need a new mitigation. But for the moment, I'm going to proceed. We don't even have over voltage shutdown, and I will hit load subtree. And if you look, I'm going to make it a little easier for you here. That's what I call an instant FMEA. I didn't have a stopwatch going, but if you compare that to a conventional spreadsheet FMEA or just even a conventional FMEA with a tabular type with many of the common tools available, I think we've identified the real problems. We've documented our problems that we have looked at and our mitigations. We might want to think about whether we want a current measurement device. How do I document that? I think I can do that. I see all kinds of reports available. I may have to pull out my manual, which is right here, but not right now. It's not that important for our activities for this webinar. We're not going to read through the manual on that one. There's a lot we can do here. A lot of reports available. I did call up the action. I want to I really want to document that. Should we add a current limiter or a current measurement on the output? So I'm going to add a new action item. And that goes, I added it twice. That's okay. That goes on to our action item report, so we just don't forget about it. FMEAs are really good, but they're better if we can solve the major objectives with less engineering hours. So think about that. You can either do this stuff yourself or get a tool that does it for you. I conclude FMEAs, as I've said before, are very effective design verification techniques that can detect design issues, quote, problems, early in the development process. I consider them to be the best possible technique to show compliance with functional safety standards. Not one of the best techniques to, in part, show compliance with functional safety standards. And perhaps more importantly, if you don't care about standards and certification, they reduce rework, which reduces cost and time to market. Some FMEA tools work hard to provide features to simplify and streamline. It's intended that makes it practical for all design artifacts, not just safety critical ones. And next generation FMEA tools will have built-in failure modes per block type and simplified effective mitigations and simplified data entry. I hope you got a piece of a message. It's not intended to be a big piece because we have 6 webinars in the series coming up. The next 3 will be streamlining integration test plans during the FMEA to FMEDA process, and a full streamlined microcomputer example demo on November 1st. So we hope you'll tune in and sign up for these additional webinars. If you have any questions, please go ahead, type them into the, I'm going to pull it out here, type them into the chat right now, and I can try to answer them, or we can get back to you later with answers. What's undetected? It means not detected by an automatic diagnostic or some kind of a manual test. Now, good FMEDA tools will cover both of those options. In the automotive standard, they have automatic diagnostics and what they call a latent fault measure, which is a manual test of some kind. In the examples, they talk about driver awareness, but we can cover those all. Let me see if I can read this. Can we get trial software? Yes. Please do not hesitate to send an email to info@exida.com. We do have a brief time period, and it also comes with a getting started Teams internet meeting to help you move fast, so you can get your trial software up and running quickly. I will tell you that when I first looked at it, all right, I never read the manual when I first looked at it. Maybe one should, but it's just not my habit. But there's a couple videos that have been produced that are available on the exida website that will help you, or you can look at these webinars. Thanks very much for the question. Another one came in. What about tracing the effect from level to level? Well, you can in many tools, but not here. I'm not certain I don't perceive value. I know that for our purposes in certification, it's best just to go all the way to the system level, the level of interest, and not worry about all the intermediate effects. I've got to get this thing. There we go. I have to get this box bigger so I can read these things. I probably did not catch it. Oh, what a great comment. Thank you. Can we add failure mode and specific custom mitigations into the expert list? Yes. I think it's really important that you be able to do that. In the end, you can delete ones you no longer wish to see. You can add new failure modes. You can add your own proprietary mitigations. Once you do that, they will go into the knowledge base library, and future projects can use them. Thanks for asking that question. Any others? All right, if you have more questions later, don't hesitate to send an email. We'd like to answer all your questions. Our objective is to help you do better FMEAs. Whether you use a tool or a spreadsheet, I don't recommend paper. Okay, I started with paper, but man, that was back just as spreadsheets were being invented. And we talked about that in the webinar number 2. So thank you all very much for your time. Send an email if you have any additional questions. I don't see any right now. Have a great day. Take care. Bye-bye.